particles of SF6 in a trillion parts of air. Well, what can we get from that information? Well, since SF6 is a greenhouse gas and is supporting the global warming potential, we definitely have the demand for alternative gases that reduce that environmental impact. Also, for us manufacturers, we have the requirements to get our products even tighter, and that we have to get into our products. That thinking we have to get in our products as well. So these tightness requirements can either be that the gas density in our gas compartment cannot leak, but also that we don't get the humidity from outside in our gas. Also, we are currently making improvements. That is definitely the case. We already have alternative gases for insulating the gas compartments. But these gases are usually, or at the moment, usually used in the middle voltage range, and therefore the gas compartments are just smaller. So still in the high voltage range, with the big gas compartments, SF6 is the only gas which is used. So our thinking is, why do we not reduce the possible incidents with handling and the measurement of SF6? And we definitely totally believe that technology can reduce and improve the human impact on the environmental development. And as I already said, we have two main factors with the product design, which is regarding to the tightness. One, like I said, is the leakage of SF6 gas, and the other thing is that we don't get humidity into our gas. And on the humidity aspect, I will now focus, because that is the point with our GAD unit. Yes, like I said, the humidity is one important factor, and that is because usually when we have pure SF6 and we introduce energy into our gas, the SF6 molecules are split. And if we don't have any other substances, any mixture within the gas, the SF6 molecules are able to fully recombinate itself. But with the introduction of humidity in our gas, the SF6 molecules are not longer able to fully recompensate itself and also develop decomposed gases, so byproducts. And these byproducts, causing corrosion, for example, and turning into, for example, hydrogen fluoride, or in the worst case into sulfur tetrafluoride, which you will notice because the odor is very strong, and it will smell like rotten eggs in your room. But how does the humidity get into our gas compartment at all? Well, there are several target points for the humidity to creep into our gas compartments. One could be, the most simple one is just handling failures or insufficient equipment, which is already damaged. We also have rubber hoses, which are connected to the gas compartment, and rubber hoses, with time they age, and through the aging, the rubber gets perforated, and the humidity can therefore creep into our gas compartment. Also, an issue could be incomplete evacuation. Therefore, I still have air or nitrogen within my gas compartment, which could already be saturated with water. Also, improper fittings could be a reason, and the permeation of gaskets. So the O-rings, for example, or as shown in the picture on the left. Epoxy insulators, over the time they get porous, and the humidity can find its way into our gas compartments. Or of course leakages in general, like destroyed valves, or not locking the hose correctly to its connection. All that could cause humidity to get into the gas compartment.
Hello, Florian. There's one question from
Yes, I'm sure.
participants. So the question is, how big is the energy needed to destruct the aseptic molecule? So I think it's related with once we have pure aseptics. So how big is the energy needed in order to make the pure aseptics to become unpure or so-called cannot be used any longer?
Well, that is actually not depending on the energy introduced. It's more depending on either the byproducts, like the humidity, which is creeping into the SF6, which is causing a no full reconstruction of it. Or for example, when you have the energy introduced into your switch, for example, there could be very fine metal particles which can get loose from the switch, and therefore the metal reacts with the SF6 and therefore cannot fully recompensate itself.
Okay,
Does
so
that answer your question? Is that okay? So pure SF6 always can regenerate itself, but the byproducts like the humidity, or for example the metal from the switch, that can cause that the SF6 is not fully regenerating itself.
okay, so in short, it's not only one actions from the heat or the energy, but it's the combination of energy and humidity and the other molecules that makes the pure aseptics to become less pure.
Yeah.
Okay.
Right.
Okay. Okay. So even though the pure aseptics is being exposed to the extreme heat, maybe under the sun, so it will not react unless there's a impurity inside.
Yeah.
Okay. Okay.
Yeah.
Thank you.
Yes, true. Thank you for rephrasing it as well. Perfect. Yes. So I continue with some fundamentals of the humidity, which is in our non-ideal gas compartment. Like in our ideal gas compartment, we would not have any humidity, and in all our gas compartments, there are water molecules which are sticking to the surface wall, and at a fixed temperature, the adsorption and the desorption process is balanced. So we have an equilibrium with the water vapor in the gas, and we have an equilibrium with the water molecules sticking to the compartment wall. But with a rising temperature from outside, for example, this leads to a higher desorption rate. So the water molecules are losing their grip from the compartment wall and are dissolving into our gas in the gas compartment. So when the water molecules from the compartment wall get loose, the humidity in the gas is rising. And of course, the bigger the surface, the more molecules I have sticking on the compartment wall. Also, we have the process of permeation, where water molecules try to get from the outside into our gas compartment. And why is that though? Because we have quite a high humidity outside of the gas compartment in our atmosphere, and then we have a very dry gas compartment. The gas is very dry. So by nature, the water molecules try to get into that very dry area. This process goes in both directions. Also from high to lower pressure is the preferred direction of the molecules. But like I said just before, since we have a very dry gas, the humidity always tries to counterbalance itself into the gas compartment.
Hello, Florian.
Also, yes?
Sorry to interrupt. We have one fresh
No
question
worries.
from attendee. So the question is, it's very great questions because commonly asked by our customer. So the question is where we should change SO2 module in every 2 years. So this one related with our gas analytic actually. So is there any special lifetime module or special technology that will diminish the necessity of changing the sensor every 2 years?
Okay. Hello, everyone. This is Manuel Michele, Product Manager for Analytics. Yes, there is a special reason for the SO2 detection. In SF6 gas, we use an electrochemical cell, and there is an electrolyte inside which reacts and also dries out within 2 years' time, or a little bit more than 2 years' time. But in order to make sure that you still have the same sense of performance, we have to exchange it in order to renew the complete module, because the electrolyte, as I said, reacts and then it is not available for any further reaction with the SO2 anymore. And this reaction actually is directly proportional to the amount of SO2 you have in a gas. And if you don't have a reaction partner, which is in this case this electrolyte, you don't get a sensor signal anymore, and this is why you have to renew it. Does that answer your question?
Okay, Manuel. So to replace it, am I correct if I say because our SO2 sensor utilize electrochemical reactions, so in short, there's a reaction even though that the sensor is not being used. So in order to make sure that the sensor is performing optimally, so we have to change the sensor. Is that the one that you just said?
Yes, apart from one point that it does not react if there is no SO2, because it is the electrolyte is especially adjusted for the SO2. But if you only leave it in a shed and you don't use it, then it will dry out, because the electrolyte is a kind of a humid substance, and this substance can dry out, and this drying out process also leads to the same effect than the electrochemical reaction. All right?
All right. Okay, thank you.
All right. Is there another question?
Yes.
Yes.
If not,
I think we have one fresh question again. So the question is, does SF6 gas, the new one, have expired date?
It can have, and it's also written on bottles, but in general, it lasts a very long time, especially when you have a very pure SF6 gas. If you have already, let's say, decomposed gas, then of course you probably won't use it. And the longer you store it, and if you have, for example, already humidity and some decomposition products inside, then you will have further reactions. And a gas that is classified as, for example, reused gas at a one time might have a worse condition after a special amount of time or certain amount of time. But for new SF6 gas, you can pretty much use for a very long time, because SF6 is like an inert gas, which from itself does not react.
So in short, for pure acetic gas, so it has an expired date, but it's very long. Am I correct?
Yes, I mean, for us in
Yes,
our lab, it's very crucial that we only use gases that are within, let's say, the expiry date. But this expiry date is derived from the fact that we very often use also mixtures from nitrogen and SF6, and in order to make sure that there is no any kind of reaction or any kind of change of the mixture, we have to make sure that we always take into account this expiry date, especially when calibrating our systems, because our measurement systems have to be calibrated on a very good level. But for simply filling it into switch gears, there is not much you have to look at, except from the fact that you use gas with a certain quality.
Okay, okay, clear. Okay, thank you. I think for efficiency, Manuel and Florian, we will store the question, the open questions, and then we will answer it later. And if there's unanswered questions, we will email to the participants. So I think it's for the sake of efficiency, we will keep the question open, and later at the end of each chapter, we will try to answer each questions. But if there's unanswered questions, we will send an email regarding the questions. Okay, thank you.
yes, sure. Like you said, if you have questions, we have on the last slide our contact details, and yeah, you're welcome to write us any message you would like to ask. From this slide, or getting back to this slide, just to summarize it, the higher the temperature and the pressure aid, that helps to discard the moisture from within from the material. And now coming to the humidity, which is already inside of our gas compartment. Well, the gas, our SF6 gas, can only absorb a certain amount of water. So, for example, like in the picture, we have a gas compartment temperature of 30 degrees, and the maximum absorption of water molecules of the gas would be 10 at that certain temperature. And when these 10 molecules are in the gas, we have 100% relative humidity, and then we also reached the saturation vapor pressure. And as I already said, the saturation vapor pressure is temperature related, and the lower the temperature in our gas compartment gets, the less humidity our SF6 gas can absorb. So on the contrary, the higher the temperature of the SF6 gas inside the compartment, the more water molecules can be absorbed. So for example, it is said that 7 water molecules can be absorbed at 25 degrees Celsius temperature. Well, like in the second picture, for example, that amount is exceeded. We have 8 water molecules at a temperature of 15 degrees. Therefore, the SF6 gas is no longer able to absorb the gas, and the vapor is turning into condensated water, which is soaking down at the bottom of our tank, and of course causing corrosion and yeah, wiring the current or the voltage. And this is the point where the humidity the relative humidity reaches 100%, is also called the dew point. Well, the temperature at that 100% humidity is called the dew point. And when we are speaking of temperatures which are above 0 degree, we are calling that the dew point, which is correctly. On the other side, like what we can see in the next slide, when the temperature is lower than 0 degrees, the water is not turning into the vapor is not turning into water, which is condensated, but turning into ice layers, and then it's called the frost point temperature. Also, what we can see from this slide, we have on the upper graph the tank temperature, and we have the correlating dew point, which is in that circumstances a frost point, because we are working in the minus degree range. But what is the message from this chart? Depending on the temperature of the gas throughout the day, which is from morning to night, the temperature is varying, and also the dew point, or in this instance frost point, is also varying. And since we talked about the dew point temperature, we have regulations for that. In the IEC, we have, we used to have a difference, but now the dew point temperature for the reuse of SF6, so recycled SF6 gas, is minus 36 degrees, and we also have minus 36 degrees for the dew point with technical grade, also speaking new gas. And then we have a standard specification from the seeker as well, which which gives us maximum tolerable impurity levels, which then is minus 5 degree temperature for the dew point, and we have a proposed maximum tolerable impurity level for reuse gas, which is set to be a dew point temperature of minus 15 degrees. So now that we know we have humidity in our SF6 gas, in our gas compartment, and that makes the operation and causes decomposition products, how do we get the humidity out of our gas? And that is the point with our GAD unit. So traditionally, to get rid of the humidity, we would look into the calendar. We have a set date, and on that set date, we would take our SF6 gas analyzer and go to the compartment and take a spot measurement. And according to the results, we would put our switchgear out of system, recover all the SF6, change it either with new SF6, and also inside the compartment we would change the absorber material, which is therefore to absorb the humidity, and then we would fill it with new SF6 gas and put the system back into service. That is also very time consuming. You need certain operators, and yeah, it's quite ambitious to do these tasks. So, but nowadays we have quite an innovative way to keep the humidity in GIS low. So we could hook up our GDHT sensor, which gives us data about the gas density, about the humidity level, and also about the temperature. These data will be transmitted to our online monitoring system, where the data is processed into graphs and charts, and from these graphs, from these data, we get a decision when we have to do our maintenance. And when we see from the curve, all right, it's time to do some maintenance. The humidity level is rising, and also the dew point is getting the dew point temperature is getting higher. Then we could easily hook up our GAD unit to the online GIS unit and start our dehydration process. And what do we do within our dehydration process? We just recover a bit of SF6 gas out of the compartment, run it in a circle through two filters, and then we just fill the dried SF6 gas back into the compartment. And then we repeat that over and over again until we really have dried the gas and the compartment completely. So how does that work? We have the GAD unit, which looks like that on the right, and we have connected to the GIS, we have a safety module, which you can see on the front end of the hose. It consists of a magnetic valve and of a GDHT sensor, which I was talking about, which can also transmit the data. The gas will flow through the hose into a particle filter, which gets rid of the larger particles and gets also rid of decomposition products. And through the vacuum compressor and the SF6 compressor, we circle it through two filters which are in parallel and which are mainly there to filter the humidity out of the gas. And then we simply put it back into the gas compartment. So another way to show it, regarding the pressure in your gas compartment, the pressure will drop a bit when we get a certain amount out, a certain amount of gas out. Then we are in the filtering phase, and when we are done filtering, we put it back in the recirculation, and we wait a couple of minutes to give the compartment and the gas time to equalize itself again. And the pressure, which is corresponding with, which is relating with the gas density, is always staying above the first trigger and the second stage trigger. To you who would like to have a more visual aspect of the GAD 2000 functions, you could also go to our YouTube site, and there is a very nice video of the functions the GAD have in addition to this webinar. We will also share the link afterwards so that everyone has the possibility to watch it. So what does happen in detail when we connect our GAD? Like I said, we have the measurement box in front of the hose, which we connect to the gas compartment, which we can see here. We can see the metal of the compartment, the metal walls of the compartment, and we have the gas compartment room where the SF6 gas is inside. And we also can notice that we have in the compartment walls humidity as well. So when we start the process, we are sucking out a bit of gas into our GHD, running it in a circle through our filters and drying the SF6 gas. So after this is done, we are pumping back the dried gas into the compartment and give the compartment a specific time to equalize itself again. So what happens, we get in this equalization phase, we get the water from the compartment wall back into the now drier air. Like I said before, the humidity always tries to get into a very counterbalanced state. And when that has happened, we again start the process, sucking a new portion of gas out, drying it, and putting it back into our compartment. And this process we do again and again, and always waiting for a certain amount of time to equalize for the humidity from the compartment wall into the gas. And with this method, we are not only drying the gas inside the compartment, but also the compartment itself. When we now look on a chart how this is evolve over time, like you can see here over a period of 20 hours, this is our complete process of recovering the SF6 and then filtering and filling it back into the compartment. So what happens is then when we fill the gas back into the compartment, our frost point, which is the dew point we talked before, is getting higher. And when we backfilled it and then recover a new portion of SF6, the dew point is rising again. Then we have a small step, which is for example, 10 minutes we wait to equalize the compartment humidity in the wall into the gas again, and then we recover another portion of SF6, and the cycle starts again. And within these 20 hours, we reduce the frost point from a starting point of around -5 degrees to a frost point of -34. So a reduction, the reduction of a frost point temperature by 29 degrees. When we look at the longer picture, we see we have one active cycle where we reproduce that process over and over again until we reach here a final dew point temperature. And this dew point temperature can be set before as a target value. And when we reach that level, or when we reach that value, the GAD automatically starts a T diffusion time 2. That is the parameter name. And we wait for example, 48 hours to give the compartment a very long time to get in the state of the equilibrium again, where the compartment walls get the humidity in the now very dry gas. And after we run out of the time period, the cycle again starts. And what is the advantage of waiting for a longer time and then starting the filtering process again? After every decomposition 2 time, like the 48 hours, the gradient of the amount of humidity which gets from the compartment back into the gas is getting lower and lower. So the potential of humidity in the gas compartment walls is getting lesser and lesser until we reach a final humidity level where you can see that the gas compartment wall is no longer be able to give humidity back into the gas. And that is also the point where we established a very stable dew point. Since the GAD 2000 is working online with the GIS in operation, we have to make completely sure that the operation is fail-safe. Therefore, we integrated components which work at the highest level of reliability and therefore are certified with the SIL and the PLD sign. Well, what does SIL stand for? Well, it's called Safety Integrity Level, and it's defined by the 2 IEC norms you can see written in the text here. Also, when you reach a certain safety integrity level. This makes it even to a performance level which is defined by DIN and ISO norm as well. And why do we need it? Yes, of course, we have a GIS in operation, but also since it is very strictly forbidden to emit any SF6 gas into the atmosphere, we can now, with these seals, we can now verify that we are only using products with the most reliable components and doing everything we can to not emit anything into the atmosphere of the SF6 gas. So what are these safety systems, or which are the safety components? Well, we have a safety PLC, and we have a safety SF6 gas sensor, which is detecting if SF6 is around in the environment of the operator. So he's not working in an endangered area. And we have, as an addition, 2 GDH2 sensors before and after the dehydration filters to just make sure the dew point or the dew temperature is at a certain level. And then we also have optional communication, which is directly connected with the gas compartment, with the gas density sensor at the gas compartment. And if we get a signal from the gas density monitoring system or the gas density sensor mounted to your compartment, we can immediately shut off the connection between the gas compartment and our GAD. The magnetic valve will react and seal the connection completely. How is the GAD operated? We have a fully automatically process structure within our MHA in our control panel. Usually at the home button, it looks like that. We have the gas compartment on the left side. We have our unit in the middle, and also we have the possibility to get new SF6 gas from cylinders or an external source. We also have the pressure level of the gas compartment, and we have a certain pressure level within our GAD. When we start our active dehydration process, we have to set certain values. We have to set limits, like the highest pressure limit. Then we have the nominal pressure of your gas compartment, which is written on the nameplate of your switchgear. And then we have then we have also to set the pressure limit for the lowest possible value. So this would be slightly above the value where your first stage alarm is triggered. Also, we set the target humidity temperature, which we learn from the two norms, from the IEC and from the SECRA norm. That is, it is -degree and at a maximum -15 degrees from the SECRA norm. And then we also can set the run after time. This was the T diffusion time 2, which I described with the longer time period. So in the graphs before, the time was set to 48 hours. After we put in the values, we confirm that, and we can start our dehydration process. Not immediately, because the GAD will also recheck the values you entered, and it will calculate the safe working range for you. And if the working range is okay, like the values are all right for the system, it shows you with the green graphics if the values you entered are not acceptable, then the GAD tells you and shows that you have to re-enter the values. And when the values are fine, when the set values parameters are fine, you start the application process. by just cycling the recovered gas in our GDA unit, always having the most important parameters on the display. Like we can see the humidity level within the gas from the two GDHT sensors I just mentioned, and we also have the pressure inside the gas compartment and the humidity value within the compartment. So again, speaking about the upper and lower limit, if we reach the lower end of the pressure limits, we will trigger a first stage alarm to the machine and automatically completely shut off our unit. Another optional feature is that we can stay always up to date on how far the process has proceeded. Therefore, we have integrated a GSM module which sends us text messages of how the status of the dehydration process is. So we have an initial status, and then we have a status at 25, 50%, and 75 until the process is completely done, and then we get a message that our process stopped and the unit is shutting itself down. With the GAD, which is our newest product, we already have done a couple of field tests in different environments. And these tests were all very successful. And to just summarize the features of the GAD, we definitely can guarantee the plant safety with the help of our double safety system. Like I said, we have the SIL certified components, and we have the safety control, which is working in parallel to the normal control and is checking every signal redundant. We have definitely the advantages that we don't have to put the GIS out of service to do all the maintenance for the lowering of the humidity. We have two parallel filters, so we can absorb a lot of humidity. And of course, with all our units, we have the high end and very reliable components like the compressors, the vacuum pump, and also we have the HMI control as well as the GSM module for remote connection if necessary. Like I already mentioned, we did a couple of field tests. We did that in different environments. So we did a couple of tests in the European area as well as in the Asian area already. So at the end of this chapter, we have a short poll which you can take. We will give you we will give you a couple of minutes to just insert your answer, and then we will continue with our second part, which is the online monitoring, and my colleague Yannick Schäfer will take over.
Okay, now it's the time for pooling. Oke, rekan-rekan sekalian, mungkin bisa dibantu kita akan melakukan pooling. Ada beberapa, mungkin satu pertanyaan cukup ya, mengenai maintenance di GIS. Mungkin nanti bisa dibantu dijawab. Yeah. So now the time is for pooling. We are waiting the participant to click the pop-up polls in the screen. Mungkin bisa dibantu teman-teman sekalian, ada polling yang muncul di screen. Tinggal diklik. Ya, mungkin bisa dibantu teman-teman yang belum mengisi poolnya. Sudah ada 49 pool yang masuk. Ya, data ini mungkin akan jadi feedback buat kami untuk memahami bagaimana sekarang maintenance di GIS dilakukan. Tentunya hal ini akan jadi record kita saja begitu ya, tidak ada kaitan apapun dalam hal pooling ini. Baik, mungkin pool akan kita segera akhiri dalam 1 menit lagi.
Danny, can you unmute Yannick, please? Is that possible for you?
Oke.
Perfect, thank you.
Yes, you're welcome. So now we are waiting for the pool. I think we can end. Okay, the pool ends now. Oke, terima kasih teman-teman, rekan-rekan sekalian, poolnya kita akhiri. Nanti di setiap chapter ada pool lagi mengenai topik yang berbeda. Oke. Oke. So, kita masuk ke chapter yang baru. Yannick, I think now, without further ado, time is yours.
Okay, perfect. So if there are no more questions regarding the GID, we can continue with the next chapter, which would be the online monitoring of SF6 gas in gas insulated switchgears. So we're changing screens now, so I hope it'll work fine. Perfect. Okay. So I want to continue basically or go into more details in the topic of SF6 related failures. Florian has already mentioned humidity, of course, which is the main cause for the GID 2000, and also leakages. And I want to go more into detail why these failures are critical, and what we as WEGrid can do about them. Exactly. So leakages in SF6 gas compartments mean that SF6 is being leaked into the atmosphere. And this is contributing to the global warming, as Florian already said, because SF6 has a global warming potential of 22,800 times the potential of CO2. That means if 1 kilogram of SF6 is emitted into the atmosphere, this equals the same amount of 22.8 tons of CO2. So this huge factor that we always have to keep in mind when handling SF6 gas. On the other hand, if leakages occur in gas compartments, this reduces the SF6 density in the gas compartment, and less density means less insulation capability of the gas, and in return, a reduced breakdown voltage and a risk of an electrical arc, because the GIS does not function anymore in the way it was supposed to be. So in the worst case, you have an electrical arc, or you have to shut off the GIS from the grid because it does not work properly anymore. On the other hand, humidity, if there's too much water inside the SF6 gas in your switchgear, it can occur that the vapor pressure saturates, and that means there's too much water, and this also can cause a reduction in insulation capability, and therefore you causing a risk of an electrical arc. And on the other hand, which Florian also mentioned, if there is an arc or simply a switching operation, SF6 gas is decomposed into different parts, into different molecules, and they might recombine with the water in the gas. And this can cause corrosive and poisonous products, which can cause a danger to the equipment and to the personnel. So let's take a look at how a GIS is operating in general over its lifetime. From the experience that we have with transmission grid operators and distribution grid operators, generally we can say that the GIS will be in service for 30 to 50 years. What we receive from the market is that SF6 related failures increase at about half of the lifetime of the GIS, so around 15 to 25 years after the installation. That means the last 50% of the GIS lifetime will be most affected by these failures. And as it is 2020 today, switchgears that have been installed before 2000, so in the 1900s, they might become critical in the near future. So SF6 related failures increase over time, and that's what we also see in this graph on the right-hand side. This is a GIS failure rate analysis of a European TSO, the information that we received for over 33,000 SF6 gas compartments. It can be compared to a typical bathtub curve, which you can see in blue, and many of you probably know from the field of reliability engineering. This bathtub curve is basically a theory indicating that if you install an equipment, the failure rate will be high in the beginning. It will decrease over time for a minimum in the middle of the lifetime, and towards the end of the lifetime, the failure rate will increase again. So you can see that especially in the second half, both graphs show quite similar behaviors. A significant increase of failures after 20 to 25 years, mainly due to the wear out of equipment caused by the facts that we have seen before. And especially in Europe, these old GIS make out more than 56% of the installed base. And if a GIS fails unplanned, it can lead to power outages and huge costs to the operators. And this is what we want to avoid with our system. And now we are showing you our approach that we are driving in this area. How do we address this problem? Our weaker asset protection approach, and our goal is to detect SF6 related failures as early as possible. In the past, what you can see on the left side, the problem with density monitoring with conventional GDMs, where how you measure density in the past with alarm context, for example, you only receive a message once the density is already below the threshold, because the alarm contacts are triggered then. So basically, you will receive the information when it's already too late. And humidity is usually only analyzed every 1 to 6 years, or even in longer periods, and also at different temperatures or different environmental conditions, such as warmer weather, colder weather, or higher or lower humidity. And this means that we have very few data with only very little informational value that we receive regarding the humidity. In the present, we are moving to the live measurement. That means we are providing a system with sensors utilized that is measuring density, humidity, and also pressure and temperature every minute to every 24 hours. So this is a very live measurement, and we call this our move from a reactive-based maintenance to a condition-based maintenance strategy. Oh, that was too much. A condition-based maintenance strategy means less unplanned outages and therefore less costs, and in the long run, a prolongation of the asset's lifetime. So you can keep your asset longer before you put it out of service. The basis for our WEGrid asset protection is our Avica GDT20 or GDHT20 sensor. We call it the enabler. And the enabler for this change to a condition-based maintenance strategy. It's a best-in-class SF6 transmitter with proven technology and several years in the market and several thousand devices already shipped and installed at the customer. The sensor itself consists of several different sensors, which I want to show you now. So first of all, we do have one pressure sensor, which you can see in blue here in the middle, with a very high accuracy and a very high sampling rate of every 20 milliseconds, measuring the pressure in absolute bar. In addition, we have 3 temperature sensors included in this one GDHT. 2 sensors measuring the tank temperature, one here, one here, and 1 sensor measuring the ambient temperature. That means we are able to have a proper measurement of temperature, and we can calculate we can account for changes in the environment temperature, because they are moving faster than the temperature change inside the gas compartment. Then, out of these 2 sensors, we can calculate the density, basically. This is an internal calculation that is done on the PCB of the sensor based on real gas behavior. And this calculation can be done with a really high precision. And finally, we have a humidity sensor in the GDHT20. It's the light blue on the bottom here, with a high precision continuous humidity measurement and a very ideal position right inside of the gas. But this is only the basis, this is only the sensor. What we are providing here is a complete system, basically. So you can see here our WEGrid approach. Let's take a look at the complete setup now. So on each gas compartment, we do have a sensor, and each sensor is then connected via a Modbus line to the next sensor. So this is a Modbus line where we can connect a big amount of sensors together. Each Modbus line is terminated at a telemetry system where the measured data is being consolidated and then transferred to wherever basically the customer needs to have this data. This can be done in several variants, and we will in the next steps take a look at what variants we have here. As I said, we are not only supplying sensors. In WEGrid Asset Protection, we are supplying complete systems, and these systems consist of components as well as services. So here we do not consider ourselves only a product supplier, but in the end, we consider ourselves a turnkey project supplier. Our components, of course, consist of the WEGrid sensors, but also process adapters and measuring chambers according to the requirements of the GIS that it is at site. We are also manufacturing customized cables and accessories, depending on what is required there, and different communication gateways. And on the other side, on the service side, we are providing the complete engineering package, data hosting if it is required, and we will also come to site and install the equipment if this is required by the customer or by the grid operator themselves. So let's take a look at the different solutions that we have and that I already mentioned before. First of all, we have the web solution. So let's take a look at the graph on the left side down here. We have our GIS, the operator is running the GIS, and the GIS is equipped with the WEGrid SF6 sensors, which are then connected via a Modbus line to the telemetry box. And in this web solution, the gateway in the telemetry box is using a mobile internet connection to send the data to our encrypted and certified data hosting center from WEGrid. And on this data hosting, we are running a WEGrid dashboard, which we will take a look at later as well, which is accessible via any web browser. Furthermore, we have a density forecast algorithm that is enabling the customer, the operator, to have a forecast for the density in the future, especially if they have leakages in the GIS. They can see when they need to refill the compartment. We will take a quick look at that later on. And also this dashboard is providing a function to provide alarms to the operator via SMS or email, for example, once the values have dropped below the given thresholds. And exactly. So let's right now take a look at what it looks like in reality. In general, you can also say that this system is quite easy to install, and we have several systems already in place. It's basically a plug-and-play solution that can be installed within several hours in the complete GIS. So regarding the forecast, this is an algorithm that has been developed by WEGrid ourselves, and basically it is providing a time window that you can see here based on the data that it has collected in the past. And of course, the longer the observation period is, the more data it has collected, the more accurate the prediction will be. So you can see here, so this is the uncertainty based on 30 days of observation of density, and based on 90 days, this forecast, the uncertainty will of course be lower. So this algorithm is basically learning and improving over time the longer it has been installed to the GIS. And this is basically what the dashboard can look like. It is a customized dashboard, so it has several different options here, but this is one way that it can look like. First of all, on the left side, you can check all your sensors values. That means you have all the tanks here, and for each tank, you can see the pressure, temperature, density, and humidity value. And you can see by the green light whether everything is okay. And once you click on one of these tanks, you can see on the right side the according graphs, and you can set the thresholds, for example, this red one here, and check the historical data as well. On the bottom side, you have the alarms that have been raised. For example, if a threshold has been crossed, you can see here this warning, and that this warning has gone to an SMS or email contact. And on the right side, you have a excerpt from the GIS layout, and you can check the location of the sensors, these green boxes here. So you will always be able to see directly where inside the GIS your issue might be if you have one. And well, there was one skipped. On the top right corner, you can see the density forecast that we have seen before on the slides. So basically, you can see here the uncertainty in which the forecast is moving, and of course, the more data it's collecting, the better this forecast will be. And this is something that is unique for WEGrid. We are the only one providing their own forecast algorithm based on our huge experience with SF6 gas in the field. I want to quickly show you a customer case for this solution, which we have recently done. We have done several, but this one is quite new and quite impressive. The goal of our customer was to easy retrofit an old GIS of over 30 years with a fully autonomous monitoring solution. And as a result, we were able to detect a leakage in one compartment, which you can see on the right side. And this leakage was quite severe, and we were able to predict when the threshold of low pressure will be reached. And according to this, the customer was able to plan their maintenance. So that means they don't need to go to the substation every now and then to check their density. They could always check it online and see if the forecast is moving, and they only need to go there if they need to refill the station, the compartment. That means no unplanned outages, and this complete solution was fully installed within a few hours. So it was basically a plug-and-play solution which we provided. The next solution, the next variant, or the second variant that we have is a little bit different. As you can see on the bottom, we are also equipping the GIS with our sensors, and the sensors are connected via a Modbus line to a telemetry box. And in this telemetry box, the data is being consolidated as before, but the difference here is that it is converted in a different industry protocol in order to be fit to the customer SCADA system or to the customer's data center. That means in this gateway, we are able to provide different protocols such as the most recent IEC 61850, but also older protocols such as the IEC 60870, or general protocols such as Modbus TCP or DMP3. And that means here we are not providing any dashboard or any forecast or anything. We are simply providing the measured data to be included into the customer's system. Also, we have a customer case that we just finished recently, where we supplied 41 sensors for a complete new GIS, because for this customer, it is now legally specified that they need to monitor their equipment in the transmission grid online. So not only GIS, but also transformers and shunt reactors and other equipment in the substation. And here we had to integrate this solution into the customer's general monitoring platform. They are running a monitoring platform from the American company OSIsoft to control all of their assets. So here the huge advantage is that the customer will have from day one of the GIS in operation a complete overview over all their assets, over their complete substation and their GIS and SF6 values. So they will be able to fully track what's going on with their substation. And here also we were able to provide a full turnkey service. That means from the beginning of the positioning of the sensors, laying the cables, designing everything, installing and commissioning the electrical equipment. So I want to end this part basically with how to move on, how to get your online monitoring started. And this is also something that Danny is working on very much. We are providing plug and play demonstration kits for immediate installation with different process connections that are available. If it is required, for example, for a proof of concept, and they can be installed within, it's even less than an hour, it's even minutes. And we will then be able, or you will be able to access this platform that you have seen before. And we can let it run for several days, at least 30 days, in order to get the first data evaluation. And then you will be able to see the results and have the first impressions of the advantage that our system provides. Well, thank you very much for your attention for this second part. And there's a second poll as well, which I think Danny will introduce to you.
Okay, thank you, Yannick. Rekan-rekan, jadi mengenai digitalization di GIS, lebih khususnya mengenai monitoring SF6, baik untuk melengkapi data kami, kita akan polling lagi yang kedua, mohon dibantu untuk diklik ya. Baik. baik rekan-rekan. Sekarang sudah ada 53 polling yang terjawab. Mungkin kita akan tunggu 1 menit lagi. Bisa dibantu bagi rekan-rekan yang belum mengklik polling yang ada di screen. Mungkin bisa dibantu. Oke, baik. Oke, baik, kita akhiri pollingnya. Terima kasih teman-teman. Okay, so now Yannick, I think now it's Florian turn again. Am I right?
Yes, yes, you're
Yes.
right.
Okay, Florian, without further ado, time is yours.
All right, thank you. So for the third and final chapter, we would like to speak to you about the GPU-X. As I already mentioned, the X in the middle of the name stands either for the basic or for the safety version, and the 2000 or 3000 is an indicator of the performance level.
Hello, Florian.
We already, yes, sorry.
Can you share the screen because I'm not able to see your presentation.
You're not able? Okay.
Yes, I think you have to share it.
One second. So
Yes,
I hope you can see my,
yes, we can see it.
my screen again.
Yes, perfect.
Like I said, okay, thank you. Like I said, third and final chapter for today's webinar. I would like to close it out by speaking about our GPU, which is our fully automatic gas handling device for all the processes we talked before in the 4 stages. This is our device for definitely handling all the SF6 related processes. When I talked about the GAD before, we were really focusing on the humidity aspect within the gas. But still, there is the absolute need from time to time to clean the gas compartments, to clean the SF6 tank. You have to, at one point, definitely go into the compartment and change the seals and the absorber materials. Well, you can prolong all that time intervals with the GAD, but in the end, there are certain times where you have to use a different gas handling unit. So also when you are maintaining to the circuit breakers, for example, the contacts, which could corrode over time, depending on the humidity level in your gas, and you also need to just maintain or replace the SF6 gas. And within the 4 stages is also the decommissioning stage, when you're disassembling your unit or the gas insulated switchgear, for example, then you have to decommission it at the end and have to pull out all the SF6 gas. So these are the areas where the GPU-X is operating. How is the GPU used? You can simply connect it to the filling port of your gas compartment. You have attached also the GDM, the gas density monitoring, or you could use, like Yannick has described, also a GDHT sensor, which transmits you the data automatically to an online platform, for example. Yes, within the GPU, we have three main components. We have the SF6 compressor, which is necessary if the pressure in the gas compartment is lower than the pressure in the storage container. So if the pressure drops in the gas compartment, the SF6 compressor will generate a back pressure of up to 40 bar, and therefore push the gas into our storage tank within the unit. Or yes, it also could transmit it through the unit into an external tank or the cylinders, for example. In addition to our SF6 compressor, we have the SF6 vacuum compressor, and this is because the SF6 compressor can only go as low as the atmospheric pressure, and to reach that final vacuum for the evacuation of 1 millibar, the SF6 vacuum compressor is doing the rest of the work. And then we have the vacuum pump, which is responsible for evacuating or filling air or nitrogen into your compartment so that you are safe to go inside and do your maintenance jobs. So after I introduced you these three main components, you see on this chart how they are laid out in the GPU. We can see from the gas insulated switchgear, we run the gas flow through a particle filter, which is a smaller filter in the beginning of the cycle. Then we bypass the vacuum compressor, if not needed, into our SF6 compressor, which pushes the gas flow through another filtering unit, which is mainly for drying the SF6 gas into our storage tank, into our internal storage tank, or could be to an external source. This is the SF6 cycle, which you can see in the orange rectangle, and we also have the air cycle, which is running through the vacuum pump and is either evacuating the air or nitrogen from your compartment, or you're filling, so you're getting the outside air into your gas compartment. Sorry. The GPU-X comes in different variations. As I already told you, we have 4 different types. We have the B version, which is available in the performance level 2000 and 3000. And we also have the S version, which comes also in the 2000 or in the more performant 3000 version. There are a couple of separators named. They all have the touchpad to control a system. They all are fully automatically, so meaning you can control every process from the display, and you can start and stop it, and the process runs by itself. And a differentiator would be that you either have the certified seal components and a gas warning system as well, and you have either more performant components, or if you are not in need of that higher performance, you can use the 2000 version. To specify it a bit more, on this level, on this chart, you can see the different capacities our compressor and pumps have. Judging from that, our portfolio is very well rounded, and every need you have in performance time, we can fulfill. So it could be that you are really focusing on the time you are filling and evacuating air into your gas compartment. Then you have the choice then you have the choice of putting in higher performant vacuum pumps, or you have the focus on the SF6 cycle. Then you can choose there from a wide product range. This is freely configure that you can freely configure, and we build the unit as you wish. As well as for the GAD, we have a video on YouTube. So if you are interested about the functions and the processes you can handle with the GPU, you're free to watch it on our YouTube channel. As said before, we will send the link to you in our follow-up email after the webinar. So when do SF6 emissions usually occur? We have the technical side, the leakage losses, which are described in the ISC norm, and then we have the handling losses. Leakage losses would be would involve technical failures, like a valve is not functioning anymore, and handling losses would be insufficiently connecting the hose to the gas compartment, or damaging the gas compartment connection while plugging the hose on it. That are all handling losses, or just overfilling, for example. And our experience has shown that handling losses are much higher than leakage losses. Therefore, we put our safety control into the GPU to just erase these man-made failures. So we are doing everything technically possible to erase failures that could occur. So like I said, wrong handling while connecting, we erase that by just having redundant signals that show us if the if the hose is correctly administered to the connection of the gas compartment. We have pressure sensors at the beginning of the function change, so we see how big the inlet pressure is, and if it's too high, we just shut it down and give you a message that, for example, the hose is not evacuated at that point, and that we have a too high pressure which is imprisoned in the hose, for example, or the pressure of the gas compartment is too high, which is not usually happening but could be. And also we could have process pressure which is too high, so a valve could not open anymore, and the compressor is pushing the gas flow against the valve, which is not opening, building up in pressure, and then the pressure has to be relieved over a safety valve, and these function and these signals from the not functioning valve will be taken into account in our safety control, and it will be shown to you, so therefore you are not going into that failure process. And as I told you with the GHD presentation before, also with the GPU, we only use components in our safety version which are certified as CL2 or performance level D components. Again, what is meant by SIL? It's an acronym for Safety Integrity Level, and it stands for the use of very reliable components. These components have been tested and they have shown a very low failure rate, which is specified in the IEC norm. And after that testing process, they can get assigned a seal sign or not. And as I told you, we are only using these components in our safety version. To create a full safety concept and a safety function, we have a safety control which is working in parallel to our process control. And with the safety control, we are making sure we are just rechecking all the data the process control is handling. And if the safety control recognizes a value which is unsafe and uncertain, it will shut down the process control and seal the necessary valves or stops the necessary components from working. WEGrid is currently the only provider of such an S-handling requirement, which has seal2 components within. And with that usage, the emission of SF6 is technically absolutely reduced to the absolute minimum. As well with the GPU, we have an HMI where you can start all the processes. For example, the home screen looks like that. We have our unit, we have the pressure, we have the weight of the gas inside our tank, we have the dew point temperature of the gas, and okay, here is no pressure shown at the moment, but you will get that information when you start the process. All our processes are listed on the right side. So SF6 recovery, SF6 filling, for example, air evacuation and air flooding. And if we like to start a process, for example, it looks like that. For the SF6 evacuation, we see that we are getting the gas out through our connection at Con 1 into our internal storage. And we always get the information about the pressure in the compartment, as well as the pressure in our internal tank, the humidity, relative humidity level, I'm sorry, and the weight of the gas as well. And we can easily start and stop it by clicking on the buttons on the very intuitive HMI interface. Also, we have a very nice function which is called the protocol. When you start a process and it automatically runs through, at the end of it, you can get the information what your process looked like, which values have been reached, which were the initial values, and it all automatically creates a protocol for you, which you can export in the PDF file onto your USB stick for documentation purposes. Yes, this is what I already mentioned. Like I said, you can easily choose from the data reporting after you finished your process. This is exportable via the US port, but we also have two other reports integrated in the GPU, which are mainly for service purposes. If really a failure happens, we can either get the system log or the event log. The differentiation between these two are that the system log is for a much longer period, just logging which process has been chosen, has it been aborted before it ended automatically, and yeah, a certain sequence of the processes which have been chosen. In the event log, which is for a shorter time frame, there is everything logged: which valve has been opened, which valve has been closed, what was the pressure level, how does the pressure at a certain timestamp has developed, and this data gives us, for repairs or for service, a very thorough insight of what has happened in the machine, and of course shortens all repair time and all the all the clearing of the process. This is what the data report looks like when you export it to your desktop. Like I said, you have the pressure at the, for example, you have the pressure at the beginning from the compartment. You have the final evacuation vacuum pressure. Also, you get the humidity values. You get the values from the internal storage about the weight and about the pressure, and so on. So very perfect for your documentation purposes. As with the GAD, you also have the function with the GPU that you can recycle your gas. Therefore, it is possible to either set a certain recycle time, so meaning you can set the cycle internally for 10 minutes. So the gas will be tried for 10 minutes running through our humidity filter. And after that, you get the info on how much the dew point has improved. But you also could set a target humidity level, like a temperature for the dew point, and then start the process until this value is reached. So this is one of the last slides, which is summarizing the key buying factors for our GPU unit. In general, we have a very high performance, which in comparison to our competitors has not always to be the same value of the performance of the compressors. For example, we also have a very efficient layout of our piping, which is very short and direct without any bends. Therefore, we are saving a lot of time and increasing our performance just by having a very thoughtful layout. Safety we discussed in detail. We have the PLD and the SIL components. And for the maintenance, we have very long-lasting intervals for the maintenance of the components. And operation, as I showed you, we have a very intuitive human-machine interface with a lot of intelligence inside that control. Yes, that is our third and final poll. After that, we have our contact details. And as I already told you, we are happy to help. If you have questions, either write a message to Danny or directly to us.
Okay,
and
thank you.
Now I would yes, thank you, Danny.
Okay, thank you for perfect presentations. So, rekan-rekan, kita sudah sampai di penghujung presentasi. Untuk yang terakhir kalinya, sebelum ke absensi, kami minta bantuannya untuk pooling yang terakhir. Pooling ini berkaitan dengan maintenance di GIS dan mengenai gas handling yang ada di GIS ataupun di substations. Baik, ada 2 pertanyaan, mohon dibantu untuk dijawab. rekan-rekan sekalian, poolingnya sudah terkumpul 49 dari 70 sekian peserta. Mungkin kita akan berikan setengah menit lagi bagi teman-teman yang belum mengisi poolingnya, mohon dibantu. Dan yang terakhir ada Google Form yang ada di kolom chat sebagai absensi. Nanti akan kami kirimkan slide presentasi dan sertifikat dalam bentuk digital yang kami juga tanda tangani. Kami akan kirimkan melalui email tersebut. Dan kami minta Pak Endang dari Surya Prima Eldrindo. Halo Pak Endang. Halo Pak.
Halo.
Halo ya Pak. Halo Pak ya.
Jelas Pak.
Jelas Pak suaranya Pak.
Oke, terima kasih. Terima kasih Pak Denny. Thank you for Yannick and Mr. Florian for the presentation. Untuk teman-teman PLN, kami juga ucapkan terima kasih kepada Bapak Ibu semua yang telah menyiapkan waktu untuk webinar ini. Jika ada pertanyaan, Bapak bisa email Pak Denny, bisa email kami, atau pertanyaan-pertanyaan yang masih belum bisa dijawab, nanti kita akan jawab per email. Untuk itu kami mohon juga, seperti yang disampaikan tadi Pak Denny, bisa diisi absennya beserta email-email yang ada, alamat emailnya sekalian. Dari SPE kami ucapkan terima kasih semua pada teman-teman PLN dan juga Pak Denny dan dua orang dari WIKA Jerman, Mr. Yannick and Mr. Florian. Thank you very much for the presentation. Dari kami cukup sekian Pak Denny.
Baik, terima kasih Pak Endang. Baik, untuk webinar yang barusan kita lihat, kami sudah merecord, nanti di email tersebut juga akan ada link untuk download recording dari webinar di siang sampai sore ini. Baik, jadi mohon dipastikan untuk teman-teman sekalian, untuk formnya mohon diisi, sehingga kami bisa mendistribusikan sertifikat, slide, dan link untuk download dari recording ini. Lalu untuk pertanyaan yang ada di Zoom ini, ada 6 pertanyaan yang belum sempat kami jawab. Selanjutnya akan kami ringkas, untuk pertanyaan yang belum kami jawab akan kami jawab, dan baik pertanyaan yang sudah kami jawab akan kami ringkas, begitu nanti akan kami detailkan apa pertanyaannya dan apa jawaban kami, dan akan kami kirimkan di berikut dengan file-file yang akan kami kirimkan. Oke. Mungkin cukup sampai di sini, rekan-rekan. Kurang lebih seperti itu, kita akan tutup poolingnya. Lalu yang ada di layar adalah kontak kami, jadi ketika ada pertanyaan bisa melalui kami ataupun Pak Endang, Surya Prima Eldrindo, ataupun bisa langsung kontak ke rekan kami di Jermani. Oke, Pak Endang, terima kasih. Pak Pur, Pak Basuki, dan rekan-rekan PLN lainnya. Oke, Yannick and Florian and Manuel, thank you a lot for your time. I think it's very good presentation, and as well as the interaction that has been occurring so far, so that we can know more about our customer needs, and as well as to really deliver the needs for our customer. So thank you very much, Florian and Yannick and Manuel.
Thank you, Pak Denny.
Thank you for having us.
Thank you. Bye-bye.
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 Bye.